Hello, and welcome to this video that will demonstrate the Intel Graphics Virtualization technology for graphics single root input-output virtualization called SRIOV. This diagram shows the new concept of graphics SRIOV, where every VM has access to fully accelerated graphics capabilities. Intel Graphics Virtualization technology now supports graphics SRIOV, which provides graphics sharing capabilities between multiple virtual machines and hosts without affecting graphics performance. So, what is graphics SRIOV? Graphics SRIOV is an emerging technology moving to hardware-based virtualization using the graphics PCI device with SRIOV support. The PCIe interface allows multiple software stacks VM called virtual machine to each get their own graphics device. For graphics SRIOV use cases, it allows a single host to serve multiple guest clients through graphics virtualization technology. The value of graphics SRIOV is a cost-effective solution with good media and graphics performance. Additionally, reducing the complexity of device and system management, thereby reducing security risks and exposure. Next, let's move to high-level graphics and display virtualization section. This diagram shows the high-level architecture of graphics SRIOV. Graphics virtualization infrastructure is exposed to system software by the graphics SRIOV standard. The exposure is accomplished using a PCIe device physical function that includes the graphics SRIOV extended capability structure. Next, the host machine has full accessibility to the integrated graphics processor unit and supports the host OS in the Linux operating software. This is the primary function of the device and advertises the device's graphics SRIOV capabilities. Each virtual machine supports Linux, Yocto project-based, Ubuntu, Windows, or Celadon Android as a guest OS and runs up to 7 VMs. Each VM operates independently of other virtual machines and is assigned to one virtual function called VF. VMM acts as a host and has full control of the processors and other platform hardware. The supported hypervisor is a kernel-based virtual machine called KVM that allows running multiple and isolated virtual environments. Next, we talk about what is a graphic microcontroller, also known as GUC. GUC is an embedded microcontroller used to perform graphics workload scheduling on various graphics engines. This section describes how to enable display virtualization in the SRIOV-based graphics virtualization environment. The display virtualization allows multi-user access to multi-monitors into a single platform. For Linux Guest OS, it allows the API to forward the 3D commands, so the host OS can be used to accelerate the graphics performance. Additionally, the Virtio GPU driver allocates frame buffers from the Virtio GPU stack. The Windows Guest OS allocates frame buffers and requests the GPU to write to them through the Miniport kernel mode driver. DV server UMD used for framebuffer copy, and passes the virtual memory address to DV server KMD, and pass the VF to QEMU. For the last section, we have prepared a demo setup with launched 4 virtual machines on the platform that uses a 12th Gen Intel Core processor. Each VM can display workload consolidation use cases by using its own display monitor. Next is the demo showcase. First virtual machine is Windows 10 Guest OS, the second virtual machine is Ubuntu Guest OS, the third virtual machine is Android Guest OS, and the last is Yocto project-based Guest OS.